Okay, concept number 6 is all about systems of linear inequalities. So basically we're taking what we learned about linear inequalities and we're adding another linear inequality. We're going to graph both of them and see where they overlap. So our objective for this one is I can graph and solve systems of linear inequalities. Okay, so that's our objective. We're going to graph and solve systems of linear inequalities. So a system of linear inequalities is two or more linear inequalities that are graphed together. So like I said, we're taking a linear inequality, and adding another one to it. So there's going to be two linear inequalities that we're working with here. Okay? A solution to a system of linear inequalities is the overlapping region of points that satisfies both inequalities. So when we graph these and we shade, you're going to notice there's going to be an overlapping region where we have a shading up here maybe and a shading over here maybe, and we're going to focus on where those two overlap. That's our solution set. Okay? So I want you to put a little note underneath here. We're going to graph and shade each line separately. And what that means is we're not going to graph both lines at the same time and then shade. We're going to graph our first line and then shade, and then graph our second line and shade and see where those two overlap. Okay? So let's do number 1 together. Luckily, these are both in slope-intercept form, so we can just graph them straight up. So this one says negative x minus 1, which means I'm going to start at negative 1. My slope is also negative 1, so I'm going to go down 1 over 1, down 1 over 1. Okay? And you can go up 1, back 1. You can do as many dots as you like. Okay? Since this is not or equal to, I'm going to have a dashed line. Okay. So it looks like that. And since it is greater than, I'm going to shade above the line, and I'm going to use a Sharpie or highlighter so you can see a little bit better. Okay, so that's this guy up here for that line. Now we're going to do this one. I'm going to start at negative 5. 1, 2, 3, 4, 5. And my slope is positive 1, so I'm going to go up 1 over 1. Okay. And since this also does not have an or equal to, this is also a dashed line. And this one says less than, so we're going to shade below that line. I'm using a different color. That is this guy down here. So you can see our solution is this region right here. All of that. So I'm going to draw a little line that's pointing to it. Solution region. Okay, so that's all we're going to do. We're graphing two linear inequalities at the same time, and we're seeing where they overlap. Okay, so let's do another example. Let's do number 3. I need to put this one in slope-intercept form, so I'm going to subtract x. Okay, I need to get y by itself, so I'm going to divide everything by -4. So since I divided by negative, I have to flip the sign. -1 divided by -4 is a positive 1/4. Positive 24 divided by -4 is a positive 6. So this line is starting at 6. 2, 3, 4, 5, 6. We're going up 1 over 4. Up 1 over 4. Up 1 over 4. We can go back the opposite way too. Since this is or equal to, I am going to, I just realized I made a mistake. Not positive 6, -6. Hopefully you're doing this in pencil, because this is math class. Okay, my bad. 1, 2, 3, 4, 5, 6. Still positive 1 over 4 though. Just a different slope, or no, a different y-intercept. It is going to be a solid line. Okay. And we are shading above because it's greater than. Okay. So we're shading above this line. All that stuff. Okay. And now this line right here is already in slope-intercept form, so that's nice. We just have to graph it. Starting at 1, going up 2 over 1. And go down 2 over 1. And this one is also going to be a solid line, since it's or equal to. And we are shading below this line. So, this is what this one's going to look like. So our solution set is this guy right here. All of that stuff with green and yellow in it. Okay. Let's do number 2, or sorry, number 5. Let's put this one in slope-intercept form, so let's subtract 4x. So we got -5y is greater than or equal to -4x minus 35. Okay. I need to get y by itself, so we're going to just divide by a -5. I divided by a negative, so I have to switch the sign. Negative divided by negative is a positive. Negative divided by a negative is a positive 7. Okay, so this time I'm starting at 7. 1, 2, 3, 4, 5, 6, 7. Going up 4 over 5. Well, I can't really do that over here, but I can go back that way. So 1, 2, 3, 4. 1, 2, 3, 4, 5. And those are the only 2 points I can fit on there, so, and it's a solid line. So there's our solid line. And we're going to shade below since it's less than. Okay. Just like that. And let's graph the other line, which is really nice. It's already in slope-intercept form, so I start at -2. And I go down 1 over 1. Then I can go back. I'm not going to go back all the way. This is a dashed line since it's strictly greater than. Okay. And we are shading above this line. Sorry, above this line because it's greater than. Okay. I haven't used pink yet, so let's go pink. So our shaded region is this guy right here, all of that. Okay, let's do a couple more. Next page. Number 7. These are both in slope-intercept form. That's nice. So we just have to graph. So this one I'm going to start at 6. 1, 2, 3, 4, 5, 6. And I'm going to go down 5 over 1. Okay, so it's going to look like this. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. And that's a dashed line. Okay, so we're going to draw a dashed line. And we're shading below this line. It might be kind of hard to tell because this line is so steep, but below this line, it's just this guy here, all of this. So you can start at one part and say, well, all of these are below the line, which means everything else over here is below the line too. Okay. And now the second line, we're starting at -1, up 2 over 1, over 1, and this is a solid line. So that's nice. And we're shading above this line, so we'll go with yellow. So that way it makes an obvious green. So the overlapping region is this guy right here. That's our solution. Okay. All right, number 9. This is the second to last one. We'll do 9, 11, and then we'll do the application in class. So this one we need to actually put in slope-intercept form. So I'm going to subtract 3x, then divide by a negative, which means I'm going to flip the sign. Negative divided by negative is a positive. Positive divided by a negative is a negative. So I'm going to start at -6, 1, 2, 3, 4, 5, 6, and go up 3 over 1. This is a dashed line, okay, since there's no or equal to. And we're shading above this line. I'll use pink this time. Okay, you don't have to be pretty with your shading. All right, and let's do the same thing for this one. I need to subtract 3x. Okay, and divide by a negative, which means I'm going to flip the sign. Negative divided by a negative is a positive. Negative divided by a negative is a positive. So these two lines are going to be parallel to each other because they both have a slope of 3x. So 3, or not 3x, just 3. Okay. This is also a dashed line. Only this one we're shading below this line. Okay. So that's all of this. So it's pretty clear where our solution set is, right in between those two lines. That'll make it a little bit easier to see. There we go. Excuse me, so this is our very last one for this unit, and then the rest of these we'll do in class together. Okay, so this first one, I need to subtract 7x to make sure I get y by itself. Negative 7x minus 32. Divide everything by 4. I don't need to flip the sign since I didn't divide by negative. Negative 7 over 4 is just negative 7 over 4. Negative 32 divided by 4 is negative 8. So I'm starting way down here at negative 8. Going down 7 over 4, but I can't go down and over this way, so I have to go back and up this way. So back 4, 1, 2, 3, up 7, 1, 2, 3, 4, 5, 6, 7. Back 4, 1, 2, 3, up 7. And this is a solid line. And we're shading above this line. We'll go with orange. Yes, I'm at school. That's why the bell's ringing. Okay. And the other line, I gotta subtract x. So negative y is less than negative x minus 3. Divide everything by negative 1. Flip the sign. Negative 1 divided by negative 1 is positive 1. Negative 3 divided by negative 1 is positive 3. So I start at 3, 1, 2, 3, and I'm going up 1 over 1, up 1 over 1, up 1 over 1. Okay, and this is going to be a dashed line. And we are shading above this line. I'll use green this time too. So our solution is that region right there. Okay, and that's where we'll stop for concept number 6. Hopefully you don't think this is too difficult. We'll do the other 1, 2, 3, 4, 5, 6, 7 examples in class. All right.